Today we are going to review the skills that we've learned over about the past week and a half or so. We've learned to FOIL and factor. We've learned to simplify square roots. We've learned to complete the square. And we've learned yesterday and the day before to work with complex numbers, to work with the I values and do arithmetic with those. So those are the skills we're going to review here. And you'll have a quiz on that stuff tomorrow. So first, multiplying. When we have two sets of parentheses and something in front of it, we want to let whatever's sitting out front hold off first. We're not going to do anything with that x at first, and we're going to take care of the two sets of parentheses by distributing through or FOILing through the parts. So I would pass out the x to both parts of the second group, x squared minus 3x, and then pass out the 2 to both parts of the second group, plus 2x minus 6. Then I would take the x that is in front and pass it out to each part of that big group now, which gives me x to the third minus 3x squared plus 2x squared minus 6x. For our final answer, we'd want to combine any like terms. So in the middle here, we have a couple of x squared terms we'd want to put together. So I get x cubed minus 1x squared minus 6x. Questions on that?
What'd you do to get rid of the -3 and the 2?
I added them together. Since they're both x squareds, we can add them together.
Oh,
And I got -1.
This is spoiling, right?
Yep. Number 2, you cannot distribute the 6 at the beginning of this problem. That won't work. You'll result in the wrong answer. Just like in the last one, we want to weight off with that x that was in the front. You also cannot just square the things that are inside the parentheses. That will give you a wrong answer. What does squared mean?
times itself.
Times itself. So I want to write this out as x plus 3 times x plus 3. And the other stuff just tags along. Then I want to do this like the last problem. Work with the two groups first. Distributing up the x. The 6 just hangs out. X squared plus 3x. And distribute out the 3. 3x plus 9. And the minus 10 just tags along. Then I can distribute out the 6 to every part of that group, but not to the 10, because the 10 is not a part of the group. 6x squared plus 18x is 18x plus 54, and that minus 10 just tags along. And then finally, when there's no parentheses left, we can combine up anything that matches. I've got some x's that match to give 36x, and I have some constants that match to give plus 44. And that's our final answer. So if you have groups, multiply the groups first, and then if there's something in front of it, multiply that through, and then finish by combining like terms. Questions? The next group of problems is on factoring. These may be kind of what I would call like normal factoring, where we're looking for what multiplies to make the last number, that adds to make the middle number. They could also be special forms, and in special forms we're really concerned with having perfect squares. And it could be all mixed up, so it's not necessarily all of one type and then all of another type. We also, as our first step, always want to check and see if there's anything that divides evenly out of every term. Okay. So, for number 3, 55 is not a perfect square. There's nothing that divides out of 1, 16, and 55. So this is kind of what I would consider to be like a normal factoring problem. What we want to do is make a list of things that multiply to be 55. So that would be 1 and 55, 5 and 11. Those are the only ways we can multiply and get 55. We want to pick the pair that in some way I could make a negative 16 out of. So how could I get a negative 16? Negative 5 and negative 11 would add to give me a negative 16. Do they multiply to give me a positive 55?
Yeah.
Yeah, we want to double check that and make sure the signs are working out. We know they multiply to make 55, but we have to check do they multiply to make a positive 55. They do, because a negative times a negative is a positive. So then our factors, x and one of the numbers, x and the other number. Number 4, we want to look at what multiplies to make 6. I could do 1 and 6, or 2 and 3. I need to make a positive 6. We want to add to make a positive 5. I think 6s are actually the hardest number to factor with, because both of those can make a 5. Right? I can do a 6 and a 1 and get a 5 from that. I can do a 2 and a 3 and I can get a 5 from that. But there's only one of those that is actually the right answer. It's not that you get to pick or choose either one, and we have to be careful with the signs. I need to multiply to make a positive 6, which means what about the two numbers? They both have to be positive, or they could both be negative, would work as well, but they have to be the same sign. If I want to add to make a positive 5, they both have to be positive. So which one, if they're both positive, will work? 2 and 3. So x plus 2 and x plus 3. Because if I did 1 and 6, one of those would have to be a negative, and then it doesn't multiply to give me the positive like it needs to. I think 6s are the trickiest. You really have to pay attention to the signs on those to make sure you're choosing the right set. Number 5, 29 is not a perfect square, so there's nothing special form about this. So we want to look at what multiplies to make 21. 1 and 21, 3 and 7. And I'm going to pick a pair that I can in some way get a 4 out of. So 3 and a 7, if I want a positive 4, what should I do signs?
Negative 3.
Negative 3 and plus 7 will give me a positive 4, and multiply to make a negative 21. So x minus 3 and x plus 7. The next problem has a typo. It's not possible the way that it's written. This is supposed to be a 49, not a 47. So this problem looks different than the other ones because it only has 2 terms. So then that should be a clue to us that this might be a special form. To be a special form, we need to be working with perfect squares. So is 9 a perfect square?
Yes.
Is 49 a perfect square?
Yes.
Yes. So then this is a perfect square factoring where we want to take square roots. So what is the square root of 9x squared? 3x. So that goes in the front. What is the square root of 49? 7. And what do I want to do with signs here? One's positive and one's negative. So they multiply to make a negative 49. And then if we would distribute and FOIL this thing out, our outsides and our insides would cancel each other, which is why we only have the 2 terms in the answer. Okay? So perfect square factoring, we look at the square roots of each of them, and then a plus and a minus to multiply to make the negative.
So that's only when we don't have like a middle number.
Yes, there's only 2 numbers. It's probably a special form of that. Number 7 is a special form, but you might not recognize it from the start, and that's okay. We can still do this one as normal because there's nothing in front of the x squared. So we want to say What multiplies to make 16? 1 and 16, 2 and 8, 4 and 4. I want to pick the set that I can make an 8 out of, so what set would that be? 4 and 4. And what would our signs be? Both positive? So it's really the same thing. So you could write your answer as x plus 4, x plus 4, but this is also really just x plus 4 all squared. I'll accept the answer either way. They're both correct. But writing them together is a little bit cleaner. For number 8, I'll look at what multiplies to make 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Lots of options with 36. Which of those sets can I make a negative 12 out of? A negative 6 and negative 6 would give me a negative 12 and would give me a positive 36 like I need. So again, since they're the same, we can really just write it once and say that it's squared, or you could write it both times.
Would this be the instance where you look for the square root though and see if there was?
Yeah, if you recognize right from the start that 36 is a perfect square, then you would try and double check that the square root of that is 6 and the middle is twice as big as that. Number 9. What do you notice about all those numbers? You can all divide by 2. So we're going to do that. We're going to put a 2 outside and divide every number in this problem by 2. Don't lose the 2. The 2 is part of your answer, so it needs to be there in that final answer. Alright, so that 2 has to stay in the front there, and then now we want to look if the inside can factor more. So now we're just going to be working with the numbers inside those parentheses and say what can multiply to make 15. 1 and 15, 3 and 5. And can I in some way make a negative 2 out of those?
Yes.
How?
With negative 5.
Negative 5 and positive 3. That 2 will continue to hang out, and we'll separate it to x plus 3 and x minus 5. Okay, but make sure that when you divide something out that it continues through the problem. Number 10, is there anything that those two things have in common? They both divide by 4. Is there anything else that they both share? They both have an x. So if I take a 4 out of the numbers I'm dividing, and if I take an x out, I'm taking one of those x's away. So what's left in the front?
X minus 2.
Just an x and then minus 2. Okay. And you can always double check that if you would distribute that back in, you should end up right back where you started. So you can always think about distributing it back in and seeing what you get. Okay. Questions?
Can we do like reduce the 4x squared to 2x minus 8x?
We can't just take a square root of a part of the problem. Okay, so our skills that we learned in this portion of our unit were foiling and factoring. We've done that. The next thing we're talking about is simplifying square roots. When we simplify square roots, what we want to do is find a perfect square that divides into that number. Ideally, the biggest perfect square possible. But if you don't happen to find on your first step the biggest, it's okay. You just keep on dividing it down. So 338. It's kind of a strange number. I have no idea what it divides by, so I grab a calculator and start doing some guess and check. Does it divide by 4? Nope. 338. Does it divide by 9? Nope. 338. Doesn't divide by 4. Doesn't divide by 16. 25. 36. 49. Okay, it divides by 2 for sure. So I started to get stumped. I don't know what it divides by. So I divided by 2, and when I divided by 2, I got 169 and 2. 169 is actually a perfect square. What is the square root of 169? 13. Square root of 2 is not a nice number, so it just stays what it is. Okay, so just kind of guess and check it on through, looking for what divides into there, and the goal is that one of the numbers should be a perfect square. You don't want to do the division if it's not worth it. So we could have also said that 338 is 13 times 26, but that's not helpful because neither one of those are perfect squares. For the next one, we've got 3 square roots there, so we would start by combining them all together into one single square root, and we get square root of 300. Multiply 5 times 6 times 10, we get 300. Then we want to look for a perfect square that divides into 300. What's a perfect square that divides into 300? 100 it is. 100 times 3. Square root of 100 is 10. Square root of 3 is not nice. So it sticks around, we just get 10 squared to 3. For a fraction, we begin by reducing if possible. 13 and 49 are not reducible, so then we separate it. 13 over 49. Each getting their own square root. Simplify them individually if possible. Square root of 13 does not simplify. Square root of 49 is 7, and that one is done. You cannot leave a square root on the bottom, but you can leave one on the top. $14, 12, and 125 don't reduce, even though they have a couple of the same numbers. So we separate those. And reduce them individually. So what is a perfect square that goes into 12? 4. So I'm going to separate this into square root of 4 and square root of 3. It's getting kind of hard to see. I'll change to black. And what is a perfect square that goes into 125? 25. It's 25 times 5. So on the top, this is now 2 square roots of 3. And on the bottom, 5 square roots of 5. You cannot leave a square root on the bottom. So how did we get rid of it? We multiply by the square root that's causing us a problem. Same thing on the top and bottom, so we're really just multiplying by what? 1. Because that's always legal. So on the top, that's 2 square roots of 15. If 2 numbers are underneath, you can multiply them together. Or if 2 numbers are outside, you can multiply them together. On the bottom, the square root of 5 times the square root of 5 gives us 5. Times the other 5 that was already there gives us 25. You cannot reduce that with the 15 because one is inside and one is outside. You can only reduce if they're in the same location, if they're both inside or both outside. Questions on simplifying square roots? Questions? So once I scroll, it's gone.
Can you go over how do you get the square root out of the bottom?
Yep, to get the square root out of the bottom, we multiply by whatever that square root on the bottom is. So on the bottom I had a square root of 5, so I multiply by that same thing on both top and bottom. Because the square root times itself will cancel out and we won't have any more roots on the bottom then.
Can you do number 10 again?
Number 10. Number 10, we're looking for what's in common to both of the terms. So both numbers divide by 4, and both of them have an x in it. So I want to take both of those things that match and bring them outside. So I bring a 4 outside, I bring an x outside. We're dividing that out of every term. So 4 divided by 4 is 1, and x with an x gone leaves just 1x.
Okay.
And then an 8 divided by 4 is 2, and the x went away, so it's just a 2. Okay, other questions before I scroll?
On number 8, would it have made any difference if we reduced it? The one with the 12 and 26.
You can't reduce unless they all reduce. And so in number 8, the x squared isn't divisible by 2, so we can't reduce just parts of it. We'd have to reduce the whole thing. All right, So the two other skills that we talked about in this unit were completing the square, and then later this week we learned, or earlier this week, we learned about our complex numbers. When we complete the square, we have two answers to the problem. We have to give the C value and then give the factored form, and this is where we have a perfect square factoring. So to find that C value, what did we do?
We divide the middle number by 2 and then squared it.
Divide the middle number by 2 and square it. So the rule for completing the square is b over 2 squared. That's what you need to know to be able to complete the square. b over 2 squared. Middle number divided by 2 squared. So we get 169 from that. 26 divided by 2 is 13. Square that, we get 169. So that is our C value. When we factor, we get an X in the front, the sign of the middle thing, and the square root of that answer that we just got, all squared. And so it's the X, the sign of the middle, and the square root of our C value, and then the whole group is squared. We also talked about how that number inside of the parentheses would come from that b over 2. Whatever b over 2 is should be that same number that ends up in our parentheses. For number 16, 7 over 2 squared. If the problem does not start with decimals, we don't want to introduce decimals to it. So when we square a fraction, we just square the top and square the bottom. So our C value is 49 over 4. Then to factor, we do the X, the sign of the middle, and the square root of the answer we just got. The square root of 49 is 7, square root of 4 is 2. Or it will always be the same thing as what we had before we did our squaring. Questions on completing the square? Okay, so then the last thing we have to review is what we've learned just the past 2 days, which is simplifying complex numbers by adding, subtracting, multiplying, dividing, or absolute value. Be careful that you look carefully at the problem. A lot of students do number 17 wrong, not because they don't know what to do, but because they misread what the problem is asking them to do. What is number 17 asking us to do with those complex numbers? What specific type? Add them. Add them. A lot of students just see a couple sets of parentheses and start foiling things. Number 17 is not a foiling problem. We foil when we multiply. This problem is asking us to add them. When we add complex numbers, we just drop out the parentheses and combine like terms. 11 plus 2i. So a lot of students will get that problem wrong, not because they don't know how to do it, but just because they read the problem too quickly and miss what they're supposed to be doing. Okay. When there's an adding in the middle of the parentheses, we drop them out and combine like terms. We do not foil. Foiling is for multiplying. Multiplying is when parentheses are right next to each other. For number 18, what are we asked to do with those numbers?
Subtract.
Subtract them. When we subtract, we need to distribute a negative through to the second group. That gives minus 27 and plus 6i. And then combine like terms. The 27 and the negative 27 go away. You can write 0 if you want, but you don't have to. You could just write 18i. 0 plus 18i is totally acceptable though. $19 now is asking us to multiply. So when we multiply, we're going to FOIL this through, passing out the 3 and passing out the 5i. I times I gives I squared. What is I squared? -1. I squared is -1. So that changes this last number to plus 20. And then we combine like terms. So we get 38 plus 18i. When we divide, our goal in all of these is to have a final answer that's like a plus bi. So our goal first in dividing is to get rid of i's on the bottom. We do that by multiplying by something special. What are we going to multiply by?
The same thing on the bottom with the opposite symbol.
The same thing on the bottom with the opposite sign in front of the I part. The other one stays exactly the same. The I part becomes the opposite. And we multiply by exactly the same thing on the top. So that we're really just multiplying by 1. Just like when we simplify our square roots, we want to just multiply by 1. Then we need to distribute or FOIL these out. So on the top, you get -35 minus 10i plus 28i plus 8i squared. And on the bottom, 49 plus 14i minus 14i minus 4i squared. Then just like in multiplying, we need to swap out our I squareds for a -1. So on the top this becomes a -8. On the bottom we get a +4. And then combine our like terms. So 35 and -8 makes -43 and plus 18i. On the bottom, 49 and 4 gives 53, and the i's cancel out, which should always happen. That's the goal of why we multiplied by what we multiplied by, is so that we would have no more i's on the bottom. For the final answer, we separate that top to each be over individually the 53 on the bottom. Questions on dividing? Last type of problem then is absolute value. To find the absolute value of a complex number, it isn't just make it positive. We plot it. So I go over to 9 on the real axis and up to 12 on the imaginary axis. Connect to the origin, and that's the distance that we're looking for. Is how far is that point away from 0, 0? We have a side of length 9 and a side of length 12. And we do our Pythagorean theorem. 9 squared plus 12 squared is c squared. It's 81 plus 144 is 225. And the square root of 225 is 15. If it's a nice number, that's great. If it's not a nice number, simplify it the same way that we did on the front page for the ones on the bottom. Questions?
Will we have to graph, like show that? Like
You don't have to show the graph, but if all I see is a wrong answer, then you'll lose more points than if I see some work that lets me know, where you were heading on that. But if I have a right answer without a graph, you'll still get the credit.
Could you do